Okay, welcome to Chapter 7, Lesson 5, Similar Triangles and Indirect Measurement. Our learning target or objective for this lesson is to solve problems involving similar triangles. We do have one vocabulary word for this one is indirect measurement. An indirect measurement allows you to use properties of similar polygons to find distances or lengths that are difficult to measure directly. And once again, you may pause the video to write down definition as we proceed to our second slide. Okay, here's our key concept for this lesson. Angle similarity. We're missing an E in there in the second angle. But it's AA. You'll need to know that for future reference. The words for this, if two angles of one triangle are congruent to two angles of another triangle, then the triangles are similar. So if angle A is missing the squiggly line, congruent to angle F, and angle B is congruent to angle G, and then triangle ABC is similar, little squiggly line, to triangle FGH. As you see on the model there, angle A has the 1/2 moon along with angle F. The angle B has the 2/2 moons along with angle G, showing that those are congruent. Okay, you're going to hit some examples here. Our first example, determine whether the triangles are similar. If so, write a similarity statement. Okay, so let's look at our angles given. We have angle E, which is 62, angle F, which is 48, angle A, 62, and angle C is 70. Oops, 70 and 48 are not congruent, so we need to see what we can do. Let's try to find out what angle G is. Angle G, what we need to do is the measurement of a triangle. Three angles of a triangle equal 180 degrees. We're going to take our 62 and 48. Let's take 62 plus 48. And that is going to leave us with 110 degrees. Take our 110, subtract them from 180. That leaves us 70 degrees. So angle G must be 70 degrees. So if we know that over there, then we can go with angle B on our other triangle. Angle B must be 48 degrees. So we can see that both triangles have at least two, if all three, congruent angles on there. So we have to say that these two triangles are similar. So our similarity statement would be that triangle EGF is similar to triangle ABC. And there you have it. It's going to me to go back into some older lessons to remember that 180 degrees is the measurement of triangle angles. Okay, let's go on to our next example. Okay, use indirect measurement. One type of indirect measurement is shadow reckoning. Two objects and their shadows form two sides of right triangles. In shadow problems, you can assume that the angles formed by the sun's rays with two objects at the same location are congruent. Since two pairs of corresponding angles are congruent, the two right triangles are similar. You can also use similar triangles that do not involve shadows to find missing measures. Okay, we're going to take a peek at an example we have here, which is a tree and a wall. A wall, 4 foot high, casts a 6 foot shadow. How tall is a tree that casts a 24-foot shadow at the same time? Let H represent the height of the shadow. Okay, in our last lesson, we talked about doing proportions, and here's where we're going to be using it again, proportions. So, once again, I said I like two fractions. One represents the tree, the other one's going to represent the wall. First, we're going to have our H representing the height of our tree. And then we're going to have what represents is similar to the H over here by the wall would be the 4, and that goes on top. And then we have our 24, our shadow, and then our shadow over our wall, which is 6. Remember, those have to match up. Otherwise, they will not, your answer will not come out correct. Make sure you're matching up shadow for shadow. So shadows are on the bottom, height's on the top. Okay, now we're going to cross multiply 24 times 4. Gets us 96. And then we're going to divide 96 by 6. And that is going to get us 16. So the height of our tree, h equals 16 feet. And that is how you use shadow reckoning to discover the height of an indirect measurement of a tree or an object. Okay, let's take a look at another real-world example. In the figure at the right, triangle DBA is similar to triangle ECA. Ramon wants to know the distance across the lake. So we're looking for D. We're going to look for the distance across the lake. As you see, and we have our two triangles here, one inside another. We have DBA, which is this inside triangle right there. And then we have our larger triangle, ECA, which contemplates all this up in here. And that's our large, but they are similar triangles, so they do have two angle measurements in common. So once again, we are going to make a proportion, cross multiply, divide, and solve for our D. So let's do it with our smaller triangle first, the ABD, the blue one. We're going to have 40 over 320. And then what matches up with our 40? Our 40 is our distance across the lake, so that will be our D. And then what matches up with our 320 is you need to add the 320 and the 162, which you get through 482. 482. Because remember, it's not just this part right here. The triangle is all the way down to our focal point, so we have to add all that up there. So you have 482. So you're going to have 40 times 482, which is going to get you 19,280. Divide that by 320. And we get a distance of 60.25. And this is in meters. In meters. I said in class the other day about proportion understanding. It's going to help you out with a lot of problems. Here's another example. Proportions, cross multiplying, dividing. Where you have comparing two things, but you're missing one item of the two. So it will help you solve many, many problems with proportions. If you have any questions, please review those problems that we did on the video. If not, write them down and bring them in to class the next day. This concludes lesson number 5.